Hi there, I'm David Taylor, and with me I have Kristel Sautet, and this is our extra credit video for IOE 265 on Poisson and exponential distributions.
A Poisson distribution measures the number of events in a given time, with the units of arrival per time. It is independent of the probabilities of each event, and the probability of occurrences are identical if events have the same length. It is also a random discrete variable. So seen here is the distribution, which is equal to e raised to the negative lambda times lambda raised to the x, all divided by x factorial. The expected value is lambda as well as the variance. X is the number of occurrences in an interval, and lambda is the average number of occurrences in the interval. F of x gives you the probability of this particular number of occurrences.
Now we have an exponential distribution. Exponential distribution pertains to a continuous random variable, the parameter for which is lambda, which measures a constant failure rate. Lambda also equals alpha. The f of x, or the PDF of an exponential distribution, equals lambda times e raised to the negative lambda times x. The cumulative distribution function, or big F of x, equals 1 minus lambda raised to the negative lambda times x. The expected value for an exponential distribution is e to the x, which is 1 over lambda. The variance for an exponential distribution is denoted as v of x, which is equal to 1 over the parameter lambda squared. Exponential distributions measures the time in between events, or the seconds between arrivals, and is also a memoryless distribution.
So we're going to show you an example of Poisson distribution. If on average 2 customers enter a coffee shop in 20 minutes, what is the value of lambda and the interval? What is the probability that no customers arrive in the next 20 minutes and in the next 10 minutes for part C? What is the probability that no more than 3 customers arrive in the next 20 minutes? For A, lambda is equal to 2 and the interval is equal to 20 minutes. The probability for B is equal to e raised to negative 2 times 2 raised to 0 divided by 0 factorial. This gives you 0.1353. For part C, you divide the lambda by 2 because the interval time is cut in half, and this gives you 0.3679. For part D, you can check, and it is probability of x equals 0 plus probability of x equals 1, 2, and 3. Next, we'll do an exponential example.
Now for our exponential distribution example. Let x be the distance between dairy farms on a rural country road. The average distance between dairy farms on this road is 7 miles. For A, on average, how many farms per mile are there on this road? Also, what is the probability that there are no dairy farms for 10 miles? For B, we'd like you to calculate the variance and standard deviation of the distance between dairy farms. And finally, what is the probability that you encounter your first dairy farm between 3 and 5 miles of getting on the road? Now for the solutions. A, we'll start with the unit distance equals 1 mile for this problem. The alpha equals 1/7 dairy farms, or 1 over 7 dairy farms per mile. Therefore, the probability of x being greater than or equal to 10 equals e to the negative e to the negative alpha x, which is equal to e to the negative 1/7 times 10, or approximately 24%. The variance of x equals 1 over alpha squared, which equals 1 over 7 squared, which is equal to 49, which is the variance. The standard deviation is much simpler. It's the square root of the variance, which is equal to 7 being the square root of 49. Finally, we have the probability that x is greater than or equal to, but less than or equal to 3 and 5 respectively, which equals the probability of x being less than or equal to 5 minus the probability of x being less than or equal to 3, which is equal to e to the negative 1/7 times 3 minus e to the negative 1/7 times 5, generically e to the negative alpha times the first x minus e to the negative alpha times x2, which is equal to, in this case, 0.1618 or 16%. Thank you very much. Have a great day.